Alright, so welcome to the makeIT Unit 2 specimen paper video for the new syllabus that would have been made active in 2022. This syllabus is from 2020 on, more than likely will probably last about 5 to 10 years. And I'm going to go through this past paper in a different way because it's a specimen paper and they have actual answers for the specimen paper. I'm going to do my answers and then compare them with their answers and see if we find any inconsistencies and then try to point out things. It's not a bash against CXC, but sometimes the things that they have in their specimen paper, they're a little bit shaky, especially when they do multiple choice. But what we want to do is we want to make sure that we understand what the syllabus requires, what types of answers that they're looking for the questions, and how your answer may not always line up with the answer that they want, but you should be able to kind of get the key points in. So let's go into the paper and pay attention to how the answers are given in their answer sheet, and pay attention to how I try to answer them and how you will most likely have to think through them while you answer them. So let's go. Okay, so we are going through the specimen paper for the new syllabus for 2022, and the first thing that you have to kind of understand is that when the syllabus changed, before you used to have the three sections used to be split up into 50 marks each. So it'll be module 1, 50, module 2, 50, module 3, 50. They have now changed that, and it's now going on to module 1 is 30, module 2, 30, module 3, 30. So it used to be 2 25-mark questions, 25 plus 25, and that would give you the 50. Now they changed that to 15 plus 15. Problem with that is, with 25 and 25, you used to have a little runway. You used to have a little, you could get a question wrong or you could make a mistake and still probably only lose 1 or 2 marks. But it wouldn't affect you too much because it's out of 50. But now that is 15 marks each and it's out of 30, your runway has been cut really, really short. So a mistake could cost you a lot in this new layout. The good thing is you have time, because before people used to struggle to finish the exams, which is why I think they probably dropped the time down. So let's go. Generally, data should be fully normalized as a relational database, defining term normalization. When they ask you to define normalization, they used to ask us all the time in the old syllabus, so in the new syllabus, nothing has changed. Basically what they added in the new syllabus is a lot more HTML stuff. But normalization is the process of making a database more efficient by removing redundancies. Alright, so when I finish a whole question, I'll go down to the answer sheet and see what they have. But usually if I have to answer a question like this, or if you have to answer a question like this, for 2 marks, you want the 2 major points. So the first point will be, okay, you want to make it more efficient. Keyword, removing redundancies is the next key thing. And if you say insert, update, and deletion anomalies, once you could say that anomalies are there, that's when normalization comes into play very well. It does those things very easily. But shouldn't be a hard one to answer because that was on all the old past papers. State 3 reasons why normalization should be used in the design of a database. This is a kind of weird one. They would tend to ask some of these from time to time. You want to say searches will be faster, you'd have a smaller file size, and the expansion in the database will be easier. So adding and removing tables is easier, right? Those are the 3 that would come to mind initially. Faster searches, smaller file size, and adding and removing tables would be easier. But we'll check to see what the answers are after. Alright, explain what is meant by the term third normal form, highlighting the benefit it brings to the database. So third normal form is, you have to explain the things that third normal form is. So I would say the table must in second normal form and have no transitive, T-R-A-N-S-I-T-I-V. Close enough, they didn't really check the spelling too much. Transitive dependencies, meaning because they say explain, you have to go a little harder to say, okay, meaning there are no fields that depend on any non-primary key fields. So basically inside the table, there must not be a field that depends on another field inside that table for its value. It must always be dependent on your primary key and your primary key alone. That makes the tables become very small. Explaining to normal form, it's not exactly straightforward. So definitely it must be in second normal form first. No transitive dependencies, and any explanation of what that transitive dependency is. Students always have a problem with that because the word transitive sounds a little difficult sometimes. Like transitive, ooh, that's a hard word to explain. So we missed out this part where it says highlighting the benefit it brings to the database. So we can say that it reduces the size of the table. One of the benefits. I'll be very interested to see what answer they have here. One of the benefits. I'll put, one of the benefits is reduction of the table size. Alright, so the sizes of the table definitely get smaller because third normal form makes the smallest possible table that you could have for them to relate. But yeah, you could go back and just pull one of these, but this one is the benefit of normalization. So third normal form, you have to go a little deeper to say third normal form is about the reduction of the size of the tables. That might be a better way to answer it. But we'll check and see what we're looking for just now. Alright, so part D, using standard notation, write the third normal form for the module result relation, ensuring that the primary key attributes are underlined. Okay, what? Write the third normal form for module result relation. Okay, I guess we have to break down this whole thing here into, oh yeah, this is one whole table here that is probably in first normal form, maybe second normal form. All they want us to do is to create a table for module result. Right, so module result will be the name on the table. You put that in capital letters and a colon, and then you put in the first, the list of fields that you're going to have inside of it. So I would say module code will be the first one, module score would be the next part, and then it will probably have the student ID as the foreign key because the student does a particular module. Yeah. So we'll have module code, module score, and I'll put student ID. The module code will be the primary key, the student ID will be the foreign key. Yeah, all this extra space here, I don't know what to tell you. It could be done in one line. So module results is the name of the function, not the table. Then module code will be the primary key. Module score relates to module code. Student ID will change based on the, well, student ID has to be there to relate to the student that it's going to be for. Yeah, and it's in third normal form because module score relates directly to module code. Student ID will change based on the module code, so that it has in third normal form. There is no dependency between these non-key fields, student ID and module score. Yeah. Okay, we'll see how they answer that. And then draw an entity relationship diagram between three relations given in the fields in part D. So we need to create three things here. Alright, so let's create a student. Definitely we have a student. We have a program or module. Okay, we definitely have module. And program. Where does semester code come in? That's kind of weird. Semester and program would relate to each other. Draw an entity relationship diagram between three relations given in the fields. Also any three, I guess. Yep. Okay. So I would put semester. Alright, so let's say we have a student. One or many students do one or many modules. Right, Each module have a module code. And then one or many students participate. You could only be in one semester at a point in time, so it'll be one semester. The students would have a first name and a last name. The module have a module code, or they'll have a student ID too. The student ID will be the primary key. Then the module would have a module code and a module score. And each semester will have a semester code. And of course they'll have their relations that have to relate to each other. We don't have to put those in. How much marks is this? 4 marks? Whoa, I think I went a little too hard there, way. Well, that is how I would have answered if it was a comp-sci, because this kind of like a comp-sci question, so only bear with me. You're guaranteed if you do it like this, hopefully you wouldn't get it wrong. I'm very interested to see what the answer look like. Alright, so that's one question. Let's go and compare the answer, the specimen answer. Now sometimes the specimen answers in my estimation would be a little weird or wrong, but I ain't trying to cause any problems here. Alright, so let's see. They said that normalization is the process of organizing data efficiently and in a database to minimize redundancy. Alright, so I gave them the redundancy efficiently. So I added in insert and update and deletion anomalies, but they didn't have that. So we went a little extra, so we still get the 2 marks there. State 3 reasons why normalization should be used in the design of a database. Or we have improves redundancy, creates data consistency, improves data integrity, saves space, improves overall efficiency. So we have searches would be faster. That would probably fall under overall efficiency. Smaller file size, we have save space. And we have adding and removing tables is easier. They have data consistency, data integrity, or redundancy. So I wonder if adding or removing tables easier would be accepted, but they would have to try to class that under yeah, they probably had a class that under efficiency. Alright, so I'll change my answer to say instead of adding or removing tables easier, because it would be easier because of efficiency, but I'll change it to I'll put in data integrity. That's better. Better data integrity. Okay, good. Next one. Explain what is the term, what is memory term to normal form. Right, this one will be interesting. The third normal form, columns are not fully dependent. The third normal form, 1 mark. What? See, there's the kind of weird stuff that you see when in the answers, and you have to ask yourself, how? I don't understand. Like they have the third normal form, 1 mark. You're just getting 1 mark for saying the word the third normal form. That's kind of weird, right?
3 marks.
Well, so by translating 3NF means third normal form, they're giving you a mark. I find that's a little awkward, but anyhow. Columns that are not fully dependent on the primary key, which is what we have, no transitive dependencies, meaning that the fields depend on no non-primary key fields. Okay, cool. And are removed. What? Okay. They said, explain what is meant by term third normal form, highlighting the benefit it brings to the database. There is literally no benefit to the database that they listed here.
Lord.
They just have 3 marks for 1, saying third normal form, 2, saying they're not dependent on the primary key, and 3, table are removed. I don't know. Alright, I don't know what to say now. That's definitely not it's a very weird answer based on what they ask. They ask for certain things. They give you a mark for saying just the word to normal form. Next one for it's dependent on the primary key, and you remove those columns. Yeah, I'm just gonna move on from that and assume that my answer is correct because we answered the question, right? I think that we answered the question. I believe so. Alright, now they said the student, okay, so using standard notation, write the third normal form for module result relation, ensuring that the primary key attributes are underlined. Okay. So we create a module result, student ID, module code, semester code, and module score. What? They have student ID, module code, semester code, and module score. They're not adding up to me. So the student ID, module code, and semester code are all keys, and the module score is just the value. All attributes are the concatenated, and two attributes are concatenated. So they have a concatenated key. I do not get it. If there's a concatenated key is when you join three fields together, or two or three fields together to create a primary key.
What?
To create a unique key in that table. Like for this particular question, creating a concatenated key not necessary because you could create the module result table just from the module code and put the score and the student ID, then relate the student ID to the student, and you'll be able to check the module that the score that the child got based on their student ID. That's a logical relationship in my view. Okay, as I said, sometimes the specimen paper, the answers are wrong. And based on the logic that I see in here, I can't see why the answer that we have is wrong, because the way you normalize, or we have normalized it to third normal form, they didn't have to have a concatenated key. Yeah, we'll just go with what my answer is correct, because what they did there, I don't see the need to group student ID, module code, and semester code as a concatenated key. That's not necessary. So they have student and module result and student grade. Student, so we have student. Oh, that is why it was only 4 marks, because they just wanted no. If they say draw entity relationship diagram between three relations, you can't draw entity relationship diagram without the diamonds. Like, you must do the diamonds to show how they relate. And look in their answer here, they didn't show anything about the relation. They just have students as a one-to-many relationship with module result, and students as a one-to-many relationship with student grade. You know, things like these just get me upset, because like a ERD diagram is always the entity, the relation, and the cardinality. They have student, module, and grade. Student, module, and grade. Yeah, I want to believe that they would question this when they're marking, because every other past paper, when you have to draw a ERD diagram, you have to draw all of the things. This is a very simplistic ERD diagram. Alright, well, even if you go extra like what I did, you should still get the marks, because you show the possible relations. But they didn't show any relation between semester code, because the semester is an entity also, because the semester has a code. If the semester has a code, that means it has a primary key. Or semester is an attribute of student. No. Alright, we'll take it like that. This answer here, I can't agree with it. Yeah, I can't agree with it. Alright, we'll go with mine. Cool. Yeah, so as I warned you, specimen papers, they sometimes have weird answers. Alright, let's go on to number 2. Alright, a database developer may use various strategies for organizing data. Explain one method in which I organize and access string using the direct access strategy. Explain one method in which data is organized and accessed using the direct. What? Explain one method in which data is organized and accessed using direct access. Explain one method in which data is organized and accessed. So how data is organized and accessed using the direct access strategy. All right, data is organized in for direct access. Data is organized by giving each piece of data a key to locate it. It is accessed by using an algorithm. And yeah, by using an algorithm. Because direct access is essentially using an algorithm to remember where everything is so you could go and find it fast. Oh, I would love to see the answer for that in specimen paper. So we'll see what happened there. Point of sale system in a supermarket operates as follows. Each item has a barcode. Data is item ID, description, and price. And each one is stored on a database. A cashier scans the item with a barcode reader and enters the quantity for each item to be sold. Total to be paid by the customer is calculated. The customer pays for the items purchased. Dedicated receipt is printed. Okay. Using the system described above, describe one entity. The entity would be the item for sure. Describe. All right. 4 marks. 4 marks, and there are 3 things. Okay, 1 entity, 1 data store, 2 data flows. Okay, so entity would be the item. 1 data store would be the database, I guess. Well, they don't have a name for it. Stored in a database. Let's just call it item database. Because I could write back the word items, but that would be kind of wrong. And then there would be 2 data flows. Data flows would be when they scan the barcode. There's item ID. That's a piece of data that flows. And then there's description. You also have receipt. The receipt is also printed and sent to the customer. Alright, there's a data flow diagram. Draw a level 1 data flow diagram with no more than 3 processes and depict the flow of data in the point of sale system described above. 6 marks. Okay. So a cashier scans each item with a barcode reader and then enters the quantity for each item to be sold. Total to be paid is calculated. Customer pays and a receipt is printed. Alright. So based on our understanding here, we have an external entity that is a person. The cashier is a part of the system. Alright, so let's say customer is external entity. Alright, so I'll change this one here. The entity is not item. And put the entity as customer. Alright, so we have the customer as an entity. We have the database as a data store. And data flows would be the item ID, description, and price. The cashier scans the barcode reader. We have to send the amount also. Total to be paid is calculated. Total to be paid is going to be sent back to the customer. Customer pays for the items purchased. Pays is our money. And a receipt is printed and given to the customer. So the receipt is our next data store. Okay, let's see if we can make sense of that. So we're going to have the customer. Customer sends in the item and the amount. So item and quantity. First thing that has to happen is that the cashier is going to have to scan barcode. When they scan the barcode from the item, they're going to pull from the database the information that is about that item. So they will be pulling the ID, description, and price. ID, description, and price. Right, so ID, description, and price comes into the scan barcode. From the scan barcode, they are now going to send the price and quantity. Price, quantity will go to a thing that will be what? Calculate bill, calculate total. When you calculate the total, that calculate total is going to send that back to the customer. Total goes to the customer, then the customer is going to pay for the items purchased and a receipt is printed. So the customer is going to send payment to a next thing called create receipt, and then the receipt is given back to the customer. Seems legit to me. Detailed receipt is printed and given to the customer. Customer pays for the item purchase. Total to be paid by the customer is calculated. Yeah, calculate the total pay. And it's, yeah, okay. 6 marks. Yeah, did I leave out anything? Doesn't seem so. How are you getting 6 marks out of this, however? That's a lot for be like 1, 2, 3, 4, 5, 6. No. 1, 2. 1, 2, 3, 4, 5. And all the arrows are 6. Wow. Well, we'll see. We'll see what to do. Alright, so there we go. Management of the supermarket has decided to allow some of its loyal customers to pay at the end of the month rather than the time where the items are purchased. So just one change that can be made to the DFT. Wow, they wicked by him. Allow them to pay at any month. Okay. A new process called I don't know, assign loyal customers or check for loyal customers. Yeah, check for loyal customer. Can check a database to see if that customer qualifies and send their bill at the end of the month. Okay, that would be my best answer. Let's compare, see what they did. So let's start with this part here. Explain one way in which data is organized and accessed in direct access. Okay, direct access. Data is stored in any order depending on available space. Data can be accessed randomly. Nah, man. Nah. That is unfair. That's a Form 5 answer, boy. That's literally data could be stored in any order and it's accessed randomly. How simplistic is that? Oh, wow. Okay. It's very hard to be like, hey, let me give them a form like a Form 6 answer and then see this. But I guess the answer that I have there would be accepted because it clearly shows that each piece of data is given a key to locate it. That means it's stored in any order. And it's, but you know, like these examiners kind of weird. They will watch the answer sheet and be like, no, they didn't say the word any order and they didn't say the word randomly. And that bothers me. Okay. I would still think the answer that I have there is correct. Just for argument's sake, let's put in key to, by giving each piece of data a key to locate it. Data is organized randomly. Alright, so green data is organized randomly. It is accessed by using algorithm. Okay, yeah, I'll leave that because it is accessed by algorithm. Look, they put the cache as an external entity. Anyhow, cache, item and inventory database, data flows will be all of those, any of those right here. That's cool. Right, so they have the customer sending the item, right? They scan the barcode. They scan the barcode, they get the item ID. The item ID goes to a calculate total function. After we scan the barcode, we get the item ID, so we send the price and quantity to calculate total. They have the receipt details. So after I'm called print receipt, the receipt info goes to the customer. Alright. I guess we had to put the cashier in because the cashier is the one that put in the quantity sold, not the customer. Yeah, that would make more sense. Because the question did say that the total to be paid by the cashier scans the 30 on the barcode and enters the quantity for each item to be sold. Okay, I agree. So the quantity not coming from the customer, the quantity coming from the cashier. So I'll put it in. Cashier. So the cashier puts in the quantity. Right. So the quantity goes in from the cashier. The price comes in from. Why payment amount coming from the customer though? Payment amount. The total to be paid by the customer is calculated. The customer pays for the items purchased. Okay, so they put in the customer payment going into the calculate total. I do not agree with that because calculating the total have nothing to do with receiving the payment from the customer. To me, receiving the payment from the customer will be creating the receipt because you have to get the payment and then give a receipt based on the payment that you received. And how is the customer going to know the total? Based on how much they have to pay. Because they're not putting in the fact that the customer needs to know the total. Because after you calculate the total, the customer will need to know how much money to pay. Unless the customer giving you the exact change, which they didn't tell you. So you have to calculate the total, tell it to the customer then sends the payment in, and then you could generate the receipt. Okay. Yeah. So that's the only difference I'll make. But I do accept the fact that the cashier has to put in the quantity. Alright, so there things are all external entities, customer and cashier is 1 mark. At least 3 processes, 2 marks, 2 processes, 1 mark. Okay, 4 to 6 data stores. You know, you see that they have 4 to 6 data stores here, right? That already supposed to be data flows. Can't really trust the specimen answers. Good try. Accurate and logically sequenced, 2 marks. Alright, I would get 5 marks for this question because I didn't put any cashier. But actually, 4 to 6 data flows. Yeah. I mean, they have to accept the fact that the total have to go back to the customer. They can't not accept that. That just doesn't make any sense. They don't just do the receipt just like that, assuming that the customer paid the exact amount. That's not how things work. Yeah. Alright, so I'll go with that. Okay, last part now, which is suggested changes. Add another data store example on account to store details in those customers and a running balance of the amount owed. No payment is made right time, purchase customer presents ID instead. So add a new process called check for loyal customer. So they just say add a data store. But if you add a data store, you have to figure out how you're going to store the data. So I have add a process called check for loyal customers and check a database to see if that customer qualifies and send them there. Yeah, they have to accept that. They have reasonable justification for 2 marks. Whenever they see this reasonable justification, yeah, that means they'll read the answer and see if it made sense. And yeah, okay, that's cool. Yeah, this should good. Because it's a process and we justified why that process is going to check and then give them the bill at the end of the month. Yeah, that's cool. Alright, that's module 1. So I hope you see so far how they could mess you up really badly with some very inconsistent answers, and those inconsistent answers are lame, but what you gonna do, boy? What you gonna do? Right, so of course, thanks for watching. You made it to the end. If you're looking for Cape IT classes that you want me to teach, you could check us out at education.makeITsimpleTT.com, and you will see all the different packages that we have for Cape IT classes. And of course, you could always come back to this YouTube channel, and there'll always be free videos here to explain different things to you. But if you want dedicated classes that will explain certain things to you and make sure you understand the syllabus inside out, then check us out, education.makeITsimpleTT.com. You'll see Cape IT, and we have a various set of classes from crash courses all the way down to full-on classes with assignments and IA assistance and paper 3 assistance. So you can check that out. Make it